Hello, you are welcome to New Focused Approach to Mathematics Basics 7. This is a revised edition, and in this video, we are looking at addition and subtraction of algebraic expression. And this can be found in page 200 of your book. We want to look at how we can add, how we can subtract algebraic expressions. Now, let's start like this. Here, how many oranges do you see? We have 4 oranges. We have 5 oranges. When we sum them up, we have 9 oranges in all. So it's so easy to say 4 oranges plus 5 oranges will give us 9 oranges. So you look here the word oranges, oranges, and then we get oranges as well. Okay, so 4 oranges plus 5 oranges plus 9 is equal to 9 oranges. Then again, I can write it this way: 5 oranges plus 10 oranges will give me 15 oranges. It makes sense, right? Good. Then again, if I say 17 bananas, okay, minus 12 bananas, what would be the answer? So look at the word bananas. We'll get 5 bananas. Good. It makes sense, right? Now, if I say 5 oranges plus 1 orange, only orange, plus an orange, will give us 6 oranges. Beautiful. Then, when we say a banana minus a banana, what do we have? I have 1 banana, I take away 1 banana, I'm going to get 0. Okay? I don't have any banana left, so it will be 0. All right, now let's translate this into variables and say, okay, so if I say mango, 1 mango, so probably here we can say banana minus banana, so B minus B. Okay, here too, if I say mangoes, I say mango, 1 mango plus 4 mangoes, I'm going to write 5 mangoes. It makes sense, right? So look at how we are using the letters now to represent what we were mentioning, the banana and the oranges and the stuff. Then again, if I say 15b, which is, let's say if it's banana, 15 bananas minus 7 bananas will give us 8 bananas. So you can see that I'm using banana, then I represent it by banana as well. So if I say 2x plus 6x, then I'm going to say just 8x. It makes sense. Good. Now let's look at it this way too. What if I say 3 bananas plus 6, sorry, 3 oranges plus 6 bananas? What will be my answer? Maybe when I put them together, I would say banana and orange, but I can't say 9 banana orange because that would not give me 9 banana orange. Like I have 3 different oranges and banana 2 are the same, so I can't add them and say 9. So here there wouldn't be any addition here. So what it means is that if I do the same thing for subtraction, I have 17 oranges. I want to take 12 oranges from 17 bananas. I mean, it doesn't make sense. You have 17 bananas and you are going to take away 12 oranges from 17 bananas. You see, it doesn't make sense. So it doesn't work that way. So if that is the case, now observe this. If I say 3m plus 4, 6b, what will be the answer? Well, it doesn't make sense either. So here we say no answer. So no answer, because I can't have 3 mangoes and add it to 6 bananas and want to write only single number to represent that. Again, if I say 7x minus 5y, of course, wouldn't give me any answer. So we can't subtract a different variable from another different variable as well. So in algebraic expression, we can only add and subtract like terms and unlike terms. Remember, in our previous pages, we've studied about like terms and unlike terms when we're looking at the terminologies that goes with algebraic expressions, right? So what we want to do is to now apply this concept of addition and subtraction to solve the following question. So if I have 18ay minus 7ay plus 6ay minus 8ay, you see that all are ay. So we can assume that this ay represent maybe tomatoes. That means we have 18 tomatoes minus 7 tomatoes plus 6 tomatoes minus 8 tomatoes. What will be the answer? All right, so our answer becomes 18ay minus 7ay will give us 11ay. 11ay we have here, then plus 6ay will give us 17ay minus 8. In all, we have 9ay. Then again, 3x squared minus 4, 3x squared y squared minus 4xy plus 2x squared y squared plus 7xy. So here you can see that like terms. So this and this are like terms, while this and this are also like terms. So I can write the like terms together like this, plus 2 also x squared y squared, then minus the 4xy, then plus 7xy. So I can now do them separately. So this one, because they are like terms, I can just say 5x squared y squared. Okay, now take note that because the variables are x squared, y squared, they are all the same, so we can treat it as an entity. Maybe let's call the whole of this as cap. Then I see I have 3 caps plus 2 caps. It will give me 5 of the caps. Then negative 4xy plus 7 will give us plus 3xy. Assuming that we call this xy as maybe water bottle. So we will say 7 water bottles minus 4 water bottles will give us 3 water bottles. I mean, that is what happens. Then the final one, we have 2 thirds, okay, a. So we can group them and say, okay, minus 1/3 a, then plus 4a plus 9a. I'm doing this because it will be easier to do the maybe fraction by fraction, then we add the rest together. So if I have 2 thirds minus 1/3 of a, assuming a is apple, so I have 2 thirds of apples minus 1/3 of apple, I'll be left with 1/3 of the apple. Then if I add 4a plus 9a, I'm going to say 13a. So now what I have is now 1/3 a plus 13a will be what? So we can find the LCM for that to get the answer. So maybe here we can say that our LCM is 3. Okay, so we are going to get 1/3 a. If you find the LCM, we are going to have, based on our fractions we've learned previously, that will give us a plus now 3 times 13 will give us 39a. Okay, so that our answer becomes 40a divided by 3. So with that addition and subtraction, our answer becomes 40a over 3. We can change them to improper fraction. Sorry, we can change them to mixed number or mixed fraction. But for now, let's leave ours like that. Our major aim is to know just the addition and subtraction. All right. So the last thing we want to do under this is to look at how to find the perimeter of a figure below. Now, talk of perimeter, we simply say adding all the sides together. I mean, the total distance around the figure becomes our perimeter. And so if I add here plus here plus here, there, we get our answer, right? So let's do that addition quickly and then we end this video. All right. So let's start from, maybe let's go from here and move this direction. So you're going to say 6y plus 4y plus 3 halves y plus 5y plus 4y plus 2y plus 3y plus 2.5. So 2.5 is the same as 5 on 2y, or 5 halves, then plus y again, then plus 2y. So we are going to add all this together and that becomes our answer. Now let's add all the whole numbers, then we add the fractions as well. So when we add this, okay, let me change the color. When we add this plus this will give us, that will give us 10y, 15y, 19y, 21, 24, 25, 27. So we have 27y. Then plus 3 halves plus 5 halves will give us 8 halves. So 8 halves y. Then when we have 27 plus 8 halves, we'll find the LCM. The LCM is 2. Here is over 1. So 1 divides 2 as 2 times 27 will give us 54y. Then plus 2 divides 2 as 1 times 8 will give us 8y. So when we put them together, we have 62y divided by 2, which of course we can write 31y. So the total perimeter of the figure is 31y. I'm sure this has really helped you to understand addition and subtraction of algebraic expressions. Thanks so much for watching.